Hello there and welcome to Lower 6 Further Maths A-Level Pure Core 1 past paper, June 2013. This is an old FP1 question from June 2013. It was question 7. So, part A looks for us to find the exact value of Z1 and Z2 summated. So, we're going to have to add the complex numbers first and then find the summation. You can't do these ones separately. 2 plus the 3 is a 5. And 3i plus the 2i is plus 5i. Now remember, the modulus is finding the distance between the complex number and the point 0, 0 on the Argand diagram. So it's a bit like a Pythagoras question. Square root of 5 squared add 5 squared is 5 root 2. Part B looks for us to find W, which is Z1 times Z3 over Z2 in the form x plus yi in terms of A and B. So what we'll do first is we'll do Z1 times Z3. So Z1 was 2 plus 3i, and Z3 was A plus bi. So expanding these brackets, we're going to get 2a, add 2bi, add 3ai, and then it would be 3bi squared, and that would be a minus 3b. The minus comes from the I squared being equal to minus 1. So now what we're going to do is we're going to have this value Z1 and Z3 divided by Z2. Z2 is 3 plus 2i. So what I need to do now is rationalize the denominator, or effectively remove the I from the denominator. So times by the complex conjugate on the top and the bottom. And my result's going to be written in this long fraction down the bottom here. So making sure that everything from the left hand side times by everything on the right hand side, I'll make sure I've got 8 terms to finish. 4 from here times by 2 over here, so 2a times 3 is 6a. Take away 4ai. 2bi times 3, that would be plus 6bi. 2bi times minus 2i, that would be minus 4bi squared. The next one is going to be 3ai times 3, that would be plus 9ai. And the next one is going to be minus 6ai squared. And the last two are going to be minus 9b and plus 6bi. And on the bottom it's going to be 3 times 3 is 9, plus 6i minus 6i minus 4i squared. So simplifying this up the top here, we'll group the real parts first. So 6a. This one here, we have an I squared. Now I squared is minus 1. So that will turn the minus 4 into a plus 4b. We have an I squared term here. So that will make the minus 6 a plus 6. And take away 9b. This will all be over a fraction of 9. The I squared would turn the minus 4 into a plus 4, so that will make it over 13. Then the imaginary parts, I'll factorise the I to the right. Minus 4a plus 6b plus 9a plus 6b. And let's go ahead and simplify all of these terms. We're going to get 12a minus 5b over 13. And we're going to get, oh, this is over 13 as well. Then we're going to get minus 5 plus 5a, sorry, and plus 12b over 13 times by I. Great. Okay, so what we are going to do now is part C. So given also that w equals 17 over 13 and take away 7 over 13i, is find the values of a and b. So what we're going to do here is we're going to set the real part equal to the real part here, and the imaginary part equal to the imaginary part up here, including the negative part there. So what we're going to do is then we're going to set 12a minus 5b equal to 17, and 5a plus 12b equal to minus 7. This is part C we're now working on. So what we now need to do is solve these simultaneous equations. So what I'm going to do is times this one by 12 and times this one by 5. And the equations I get are 144a minus 60b equals 204, and 25a plus 60b equals minus 35. Okay, so I can see I've got a plus 60 and a minus 60 here, so if I add my two equations together, then I'm going to get 169a equals 169 over here. A will therefore give you the value of 1, and plugging that into one of these here, B is going to give you the value of minus 1. Great, that was a difficult question. Part D, we're not over yet. Find the arg of W given your answer in radians to 3 decimal places. So we have 17 over 13, take away 7 over 13i. So remember, this is going to be the angle on the argand diagram. 17 over 13 is going to be to the right, 7 over 13 is going to be down here. So we're going to have 7 over 13 going this way and 7 over 13 going this way. Our answer is going to be negative because we're on the bottom of this argand diagram. So tan minus 1 of the opposite over the opposite over the adjacent. 7 over 13 over 17 over 13. Get your calculator out, make sure you're in radians mode, and you get 0.391. That's not the final answer. Our answer needs to be negative because it's on the bottom, so the argument of W is minus 0.391. Remember that for these sorts of questions we can always check our answer on the calculator. Head over to complex mode, push the options button, you want option 1 for argument. Type in your complex number, 17 over 13 minus 7 over 13i. Make sure you're in radians mode for this. You will get an incorrect answer if you're still in. To go to shift menus to the setup, click on the angle unit and change your angle unit to radians, and press enter on that, and you get minus 0.3906. The 6 will round the 0 up to a 1, so our answer is minus 0.391. 11 marks for that biggie.